Hello and welcome to my presentation about comparing the big clouds. I'm a Microsoft developer, so I have an Azure perspective, and I'd like to explain what Amazon AWS and Google GCP bring into the picture. In the end of this talk, I would like you to know that there are more than one cloud and what is different and what is equal between them, so that you can have the big picture when you need to decide which cloud to use or which service in which cloud. First, let's introduce myself. I'm Bart Kooijmans. I am a software engineer at the team Rockstars RT. I love Microsoft and Azure and talking about it, sharing my knowledge in speaking about in sessions. In my spare time, I'd like to do sports, and I have a family which I enjoy doing fun days out with. If you'd like to join me on Twitter, I'm at Bartholomew85, and you can connect with me on LinkedIn as well. So why do I love Azure? Well, like I said, I am a Microsoft developer, let's call it that way, and I have been in the Microsoft career with 14 years for now. I use Windows, Visual Studio, Microsoft SQL, Microsoft.NET. It's all the Microsoft stack. So when I needed to use the cloud, it was very natural to grow into Azure because I was already on the Microsoft stack. I didn't do any research. I didn't look any further. I knew there were other clouds, but I just didn't consider them. I had a very big tunnel vision. So I went into the Azure tunnel and I got pretty far in it. It works out just fine. I haven't had any time when Azure didn't provide what I was looking for. And it has a good integration into the Azure developer, the Microsoft developer ecosystem. If you ask me, going to the cloud is actually a given. This is a picture of a cloud in Amsterdam, uh, which is just on the Earth. It's not a cloud anywhere else than a normal data center that you're used from before. So I started with a desktop running the server for the company. It was a computer under the desk, and then we grew into a data center in a nearby town or city. And when that was not sufficient anymore, we grew into the cloud. So that's what everyone is doing now, and I'd like to talk to you about why the cloud is good as well. Um, the cloud has many preferences about comparing to the data center traditionally. You don't have to manage the servers in there. You can pay by minute. You can pay by hour. You don't have to buy an entire rack in the data center and be responsible for it for the entire lifetime of that hardware that you bought. So if you ask me, going to the cloud is a given. It's very important to embrace it in these times. But which cloud? As a Microsoft fanboy, I would say Azure is the best, right? But then I was working as a consultant, and I have a side job which is at the Fontys University. When there are graduates, they need an external expert. And with that, there is a graduate that has its own company where he graduated. He has the university that's accompanying him. And then there's an external expert that has some second or third opinion on what he does and if he does it well. And I was the first time I was a external expert on an Azure topic, and the second time they asked me, "Would you like to do it again?" And I said, "Sure, give me another cloud topic." And then the next time they came with me with an AWS, the Amazon cloud. So I was a bit surprised. I thought, wasn't it clear that I had an Azure cloud? Why would I go into the Amazon cloud? So then I went to look into it, and I did the graduation with the fellow, and I actually thought it was very similar to Azure. So that opened my eyes that, oh, I knew that. I knew that kind of technology. Oh, they have a serverless function. They have a container solution of infrastructure as code. I knew that from Azure, but I never stopped thinking about why Amazon would have it. So that's when I looked into Amazon. And well, I was quite surprised about how mature and complete Amazon is, maybe even more complete. And so I want to challenge myself. I did already have some study for the Azure developer exam. And then with a few days of studying, I went and sit for the AWS Certified Developer Associate, and I passed. I saw lots of similarities. If you take the Azure Developer exam, if you study the quirks for that, then you only need to study extra the quirks for AWS and the right technology naming. Currently, I'm studying for the Google, the same, but for the Google Cloud exam. And again, it's like everything is the same, but it has a different name and it has different quirks. So you can study it very easily if you have another one in your pocket. So let's talk about Amazon AWS because they were the first. They started in 2006. Amazon, you all know it as a book selling store. They had lots of rack space available in the data center. They even had a data center all around the globe. And they decided to rent out all the extra space in their data center. And that worked out pretty well, as you know by now. It's $1 billion it's a $1 billion business. Yeah. Like I said, they started in 2006 and they had a global coverage, and they were competing with the traditional data centers, which have only a data center coverage. There wasn't even a sign of global coverage then. And what they did, they started a new age of software engineering, because now if you design against the cloud, you design with other things in mind when you're writing your software. You need to be fault tolerant. You need to talk about resilience and scaling. It's much more a topic than it was before. Another example is the ready-to-use services. They are managed services and SaaS or other IaaS, oplossingen, infrastructure or software as a service, in which you just take the service and you don't manage the hardware that's lying underneath. So you can have a database as a service without managing the hardware, or you have a virtual machine as a service, or just a function as a service. Another thing that's very typical for cloud computing is that you're charged per usage, and it's very scalable. So if you have a virtual machine, you need it for an hour, you pay exactly for the minutes or maybe seconds that you used it. And like I said before, if you're in a traditional data center would have paid for a hardware of a virtual machine, then you have paid for it for the entire year and not for the single second that you used it. For now, there are more than 200 services, and it's very globally distributed. If you can see in this picture, you see all the blue dots. That's where a data center is, and every month, every year, there are data centers coming extra in. You also see that's a very Western approach. It has America, Europe, and some places in Asia, but it's not entirely global coverage, but that's for every cloud. Then Microsoft followed in 2010. They did reasonably the same coverage. You'll see the same amount of dots around the globe, the same packages, the same services which they provided. And they had one unique selling point, if you ask me, that is the popular developer package, which is .NET or any developer package that is spawned from that. You develop for Windows, for SQL Server, and you use Visual Studio, and it's all integrated perfectly with each other. Google joined very shortly after that. They already have their own data center as well, just like Amazon started, and they rented out the spare space that they had. Google is, well, if you look at AWS and Azure, you see that they are very enterprise oriented, but Google is more consumer oriented. You might know them from the search, the YouTube, the Gmail, the Google Docs or Google Drive. And which is Google's approach for the cloud is more that they provide software that they created themselves. So if they have they created Kubernetes a while ago, and that was a unique selling point, and which they put in the cloud. That's mostly their approach for putting stuff in the cloud, where AWS and Microsoft put stuff in the cloud that's more ops related, like everything you can host, they host it for you. Google has an approach for what things they invent themselves and they bring that in the cloud. And in time, they grew into each other. Well, let's look at how big each cloud is. There's a big research company in the world. It's Gartner. They make magic quadrants for every company structure in the world. So as well for cloud infrastructure as a service. Every year you see Amazon leading the pack by far. Microsoft is coming very close. This is which they stated in almost a year ago, 2020. Google is coming up very close. You see the leaders in here. And far behind those three, there's other clouds like Alibaba, Oracle, IBM, and some are competitors like these three. Those have 200 services, which is everything you can find is in there. But these might be more niche players, like it says over here. So IBM might be more into VMs, and Alibaba might be more into VMs as well, but Salesforce might be more into a CRM structure. So they have a niche, and they're not using the entire broad breadth of services that the others have. And in the markets, all these three services that I talk about, AWS for Amazon, Azure for Microsoft, and GCP for Google, they all are widely used on the biggest companies that are out there. So AWS has a marketing sheet which states they're used by Netflix globally and by the Formula One. Azure says 95% of the Fortune 500 is using their services, and GCP states that among others, Nintendo or Toyota is using them. So they're all making very sure that they are a very good player, and they would like to know that. Sorry. And they would like to know that you can use them because the big players use them as well. And it's not that the markets are that the companies that are stated here use them entirely for their own. It could be that they use parts in Azure and parts in AWS as well. So the size and footprint are about the same. If you see what I just showed you, that the global coverage is about the same, and they have all hundreds or tens of services. So that's about the same. Let's look at about what services they have actually. So if you look at Azure, there are so many services that they need to be categorized and color coded. So there's a very handy website I'd like to share. That's azurecharts.com. And if you look at that, they have every service for Azure. So each 200 services, maybe less if you look at this view. And it's color coded for compute or databases or AI and machine learning. And then in the vertical row, it's what is new, what is recently released or updated. And further down, it's what is later on released or updated. So you see here that there's so many services, they need to be colorized. And if you have this in mind, that Azure is big, and if you want to compare it to AWS, the first thing I did was Google for it, and I found a very good website, which I would like to show you now, which is this website. It's on the docs.microsoft, and it is a comparison from AWS services to the Azure services. There are comparisons the other way around, and there's comparisons for GCP as well, if you want to look into it. And you see at the scroll bar, it's a very long page. Every service in AWS is counter matched with the Azure service that's related to it, and there's description if you want to know what it is. So every AI service in AWS has an Azure counterpart. Big data, they are all matched. There's an AWS service here, which has a counterpart in Azure. Then if you look at this very long list, if you have virtual servers, there's elastic compute, there's virtual machines. It goes on and on. Every service, which opened my eyes, that I thought that they would have some difference, but in fact, AWS and Azure they grew into each other, and everything, the one invented, the other copies, and the other way around. So this page is one of the starting pages for my AWS adventure when I was looking at Azure, and I thought, whoa, let's look into it any further. So of course, these color codings and categorizations have been done by the community for AWS as well. You see a periodic table, which states all the services in the handy color coding for everything that's compute or everything that's machine learning. And for Google, there is the same type of sheet, is a developer's cheat sheet, in which every service has a maximum 4 words explanation if you want to cheat what was there. So this is updated very often. And you see as well, there's a category for compute, storage, database, and then it's listed what's already in there if you want to drill down into it. And I'm now following a Cloud Guru course. A Cloud Guru is a very good learning platform if you want to use or learn the cloud platforms. And what I said before is that I got from here. They state that a GCP was built from dev towards ops infra, and AWS was built from infra towards dev, which means that AWS, they host everything that can be hosted and they make it managed. And maybe that is what's one of the key drivers of their success. They release existing services that customer need and ask for. And GCP has another approach. They just release what they built and needed. So they invented Kubernetes. They use TensorFlow a lot for machine learning. They have written papers on MapReduce. They've created Bigtable, BigQuery, and Spanner. And then they release that in their Google Cloud so that you can use it as well. So Google is very developer focused, and then they released that. And in the end, they grew into each other because everything AWS has, most of it has GCP as well, and the other way around. So let's start looking at some service comparison. So they all started with virtual machines, and file storage, and message queuing. This is the basis of all cloud computing. Everything that's built is built on top of this. So if you have a database as a service, it's running on virtual machines and file storage, and maybe on message queuing to work the magic underwater. In Azure, it's called very naturally. It's a virtual machine, it's a blob storage, it's a queue storage. And in AWS, they have other namings, but you'll see some similarities in it. You'll have the elastic compute. Elastic, you'll see that a lot. And you have the simple storage services and the simple queuing services, which is names they use a lot in AWS. And GCP does something similar. They call everything compute or cloud. So it's the compute engine or the cloud storage. From databases, which is the next they all grew into. So Azure has a key player for Microsoft SQL. If you have done it before, a database, creating a database, hosting it is a lot of work. You need to maintain it, you need to upgrade it, you need to have the hardware supported. And it's a very nice feature to have just the database hosted by Azure, by Microsoft. So you have a connection string, and when you're that's the only thing you need to know about it. AWS does the same. They have the relational data service, the RDS, which is MySQL, Postgres, and Microsoft SQL. And GCP does it with Cloud SQL, but they don't offer Microsoft SQL. If you look at the virtual machines like before, the Windows is supported on every platform. So even GCP and AWS offer Windows machines, but in practice, they might be using Linux more. There's the normal relational databases. There's also the NoSQL or document DB databases. Azure has a Cosmos DB. AWS calls it Dynamo, and GCP calls it the Bigtable. It's very useful if you have big databases and there's no relation in it, so it's sharded and scaled easily. Then there's the memory cache, which is a Redis product. Azure calls it the Azure Cache for Redis. AWS has the Elastic again, Elastic Cache, and GCP calls it the Cloud Memory Store. Every service in the cloud is hosted in a software virtual network. So there's not many surprises in the naming here. It's a virtual private cloud or virtual network, which means every service that you host is hosted inside this network. So you can have a private public cloud if you want. As a developer, when you're developing a web app, this is an architecture that is created by Microsoft. It's hosted on the docs.microsoft.com. And it states some services that you'll need if you'll create some website. So there's a queue for messaging, there's a serverless app, there's an IIS web app, there's a DNS, there's a front door, there's a search and database. And what I would like to give you as a takeaway that each service in this chart or in this diagram is available in every cloud out there, so in AWS and in GCP as well. Some other service comparison is it's very popular nowadays to use containers. So I've used Azure Container Registry and the Azure Container Instance to run just one instance, which works very well. If you like more scaling or set up a network in between, then Kubernetes comes into place. So you see GCP, we mostly invented. Kubernetes, they host it. But Azure and AWS followed soon with a Kubernetes hosted service. You don't pay for the Kubernetes overhead, but just for the used nodes and pods as virtual machines on the water. There's a container running service as well, and a container registry in all three as well. In parts of security, every cloud works with identity and access management, which is the IAM. Azure has the Active Directory, which it's inherited from Windows, of course, and there's role-based authentication in every cloud. It's the most important authentication out there. If you'd like to store secrets, like in your personal password manager, there's the Key Vault in Azure or the KMS, the key management service in the other clouds. It's very good for DevOps if you'd like to have a password somewhere to not have it in your Git repository or code repository, but to just host the password in a managed service and then have IAM do the lookup in there with rulings defined in the IAM. For traffic management, of course, that's very important. I'm a great fan of the API management. So if you're creating an API, then API management sits in before, which does some traffic management. It does security management. It does some DDoS filtering. And GCP has a great product, which is called APG. AWS has the API gateway as well. Traffic management also includes a load balancer, the CDNs, or other traffic managers. As a web developer, we saw there are serverless applications, and there are virtual machines in which you can host, but there's also the app service, which is almost an IIS as a service. You can host some Node.js app or a .NET website app in there without ever using a full virtual machine with an IIS on it. AWS has that with Beanstalk and GCP with the App Engine. For monitoring as a web developer, it's very good to have CloudWatch in AWS or Application Insights, very useful. And for serverless, I said there's a Lambda, Azure Functions, and Cloud Functions in GCP as well. And finally, as a software engineer, you might want to use Azure DevOps or a Git repository. When I first was into this comparison, I thought that Azure DevOps was some kind of special. It was a unique selling point because Microsoft has a big developer community behind it. But then I saw this comparison website that I showed before, and I saw that Azure has Azure DevOps, which has CI/CDs and Git repositories and the package manager for artifacts. AWS and GCP follow along, and they use that as well. Yeah, so they offer that as well. So now we've seen lots of services. I won't use them all, but when would you use what? So Google is very big in big data and in machine learning, and AWS and Azure is very good if you use any service in general out there. They mostly have anything that you would want for. So integrating is very easy. If you're a C# developer, you have a NuGet package, you have in that package a C# interface, and you have some credentials like connecting to a queue or connecting to a database or file storage. You just use a password or role managed credentials. And for Azure and AWS, it's the same. You just have a package in it, and then you can use it. It's very abstract and straightforward. Another thing that is important is the cost. When I was looking into this, they said, well, Amazon is much cheaper. We're all moving to Amazon because it's cheaper than Azure. Well, I tried to look into it and make a statement, but it's very difficult for the big spenders. They can go for discounts with the big cloud vendors. And if you're just a small one-person army, then it's very difficult to compare them as well. It's like apples and oranges. I tried to look at the 2 CPU virtual machine with 8 gigabytes of RAM. They're all in all 3 clouds that I mentioned, they're about 10 cents per hour to use. And yeah, well, if you use a GPU or more memory, then of course you pay more, but it's very difficult because the cost they fluctuate amongst the weeks, months, years. Another great example is the outages, which we had last week as well in the Microsoft world. In December, there was an authentication failure in Google as well. But in general, it is very difficult to make a list of which outages were there. Of course, there are post-mortem reports, but there's no convenient list to list all the outages and see if they actually had their SLA met, which they are very proud of. And finally, the certification ladders are mostly the same as well. So there are fundamental layers, which is for a zero experience. If you just want to talk about it, if you want to sell, or if you want to be a manager and talk about it. If you want to be a developer, there's the 6 months experience, which is the associates. And then you also got the professional layers for 1 to 3 years experience. So my conclusion, is Azure DevOps unique? Is a Windows license unique? Is Microsoft SQL unique? Well, not at all. So the Azure DevOps is met with CI/CD pipelines in AWS and Google as well. Windows licenses for virtual machines can be bought on AWS and Google. Microsoft SQL licenses can only be used on AWS, not on GCP. So as a software engineer, the basic stuff, it's all equal to me. It's very difficult to find any differences. If you look any further, there are, of course, niches in which they perform any better. But in general, you can very perfectly create an app on GCP or on AWS or on Azure. Maybe that machine learning is better or cheaper or more mature on GCP, or .NET integration is better with Azure, but you can perfectly host a .NET app on GCP or on AWS as well. So my takeaway for this session is you see the whole picture. There are perfectly valid reasons to stay in Azure, but Google and Amazon are very good clouds as well. So thank you for joining my session. Now is the time for some questions or feedback if you'd like to know. You can still join me on Twitter at Bartholomew85 or join me on LinkedIn. Yeah, thanks for joining my session. Let's hear some questions now.